Okay, so in this video we are going to be talking about population variance and population standard deviation, which honestly you cannot calculate the standard deviation without calculating the variance first when you are doing it by hand. So that's something we need to really make sure you understand. They are so closely related. The standard deviation is really what we look at most of the time because the standard deviation is in the same range of numbers that your data set is, and your variance is always squared of what your data set is. What I mean by that, if I'm looking at test scores and my average test score is a 70, my standard deviation may be 5, so 5 points is what the standard deviation for the test is. That means I expect people to be between 75 and 65. About 65% of my people should be between those two values as far as who scored what. Variance is double that. So my variance for, if I had a standard deviation of 5, my variance would have been 25. Okay, so we like to talk about standard deviation over variance just because it takes our numbers back to what the scale is that we're using in our data. Alright, so let's actually talk about this and talk about how we're going to calculate this. So we do have a couple definitions. This is the difference between the score and a mean is called the deviation. To make sense, how far away a score value is from the actual mean. When we find the variance, we do the average squared distance from the mean. Okay, so basically what that means is we're going to take all of those deviations, the score minus the mean, and we're going to square them, add them all up, and divide them by however many pieces of data we said. That's how we do our averages. Okay, and then the standard deviation is just the square root of our variance. So this provides us a measure of the average distance from the mean. So that's really, again, we like to use the standard deviation over the variance, but again, in order to find standard deviation by hand, we actually find the variance first and we take the square root of it. So let's talk about population variance. Now, we're being very specific. We do have a population variance and we have a sample variance. It's very important when you are doing standard deviation / variance that you know whether or not you have a population, which means you have the value of every single person in that particular population, or do you have a sample of that, because they are very, very similar, but yet different. So vast majority of the time, guys, in the real world, you'll probably very rarely ever do the population variance. You'll do the standard or sample variance and sample standard deviation, because we typically don't have an entire population to work with. So the first thing you're going to find is the sum of squares. Okay, so this is the sum of all of your x's minus your means squared. Okay, now that's the definition. We have a definition and then we have a way that we compute this much easier. And the computational formula is we square all of our variables, all of our data points, and we add them all up. And then the other thing we do is we add all our data points up, then square it and divide it by however many data points we have. So we can find the sum of squares that way much easier than doing the data point minus the mean, although both particular definitions will actually work. And then once we find the sum of squares to find the variance, all we're going to do is take whatever that value is and divide it by n. So we take that sum of squares and divide it by n. Alright, so I do have an example here. So we're going to find the variance of just these 5 numbers, 1, 9, 0, 2, and 3. We don't even have to find the mean if we use the computational formula. If you use the definition formula, then you have to figure out what the mean is. Okay, so the first thing we're going to do is we're just going to add up the data points. That's going to be our sum of our x's. So sum of our x's is 15. The next thing we're going to do is we are going to take each of our data points and we are going to square it. So 1, 9, 0, 2, and 3, we're going to square each one of these. We're going to get 1, 81, 0, 4, and 9. And then we are going to add all of those beautiful numbers together and we're going to get the sum of our x's squared is 95. Okay, so those are the big 2 pieces of information I need. I need my sum of my x's, which is 15, and the sum of my x's squared, which is 95. The other piece of information I need is how many data points that I have, and in this case my n is going to be 5. So now we can figure out what our sum of squares is. So we're going to do 95, remember that's the sum of my x's squared, minus 15 squared. Remember, the 15 is the sum of all of my x's. And I'm going to divide that by 5. Now remember, my order of operations says I'm going to do the 15 squared first. So I've got 95 minus 225 divided by 5. So I get 95 minus 45. And lastly, I get the sum of my squares is 50. Now remember, this is not my variance, that's the sum of my squares. So to find my variance, I have to do the sum of squares, which is 50, divided by my n, which is still 5. So 50 divided by 5, and we get that the variance is 10. Now again, we don't use variance a whole lot because it's double or squared of whatever our data value is. So what we want to do is find our population standard deviation, which once you found the variance, the standard deviation is super easy to find because it's just the square root of whatever that value was. So all we're going to have to do to find the standard deviation of our data set, that 1, 9, 0, 2, and 3, is we're just going to take the variance and we're going to take the square root of it. The variance, it was 10. So the square root of 10 is 3.2. So our standard deviation for our data set is 3.2. I hope this helped you in finding the population standard deviation. Let me know if you have any questions or would like any other examples.